So in this first question, so we have to choose from the following compounds to answer the questions. So a lot of these, most of these are something you should probably have known. Aluminium iodide would be AlI3. If you think about the valency of Al being a +3 and the valency of iodine being -1, so that will make sense. Ethanol is CH3CH2OH. Glucose is sugar, C6H12O6. Lead 4 chloride, so it's a Pb +4 in terms of oxidation state. If you don't do oxidation state, you should be able to appreciate that is the valency, okay, that give rise to this oxidation state concept. So you could think of it as the valency, and therefore you get PbCl4 as the formula for lead 4 chloride. Lithium bromide, so it's an ionic compound, Li+, Br-. Magnesium carbonate, Mg2+, CO3 2-, so you get MgCO3. Methane is CH4. Potassium phosphate, this is an interesting one, K+ and PO4 3-, so you're going to get is K3PO4 because you need 3 of the +1 to balance out the 3- charge of one phosphate ion. Silver nitrate is a very common reagent used in qualitative analysis in your practical paper to test for chloride, bromide, and iodide. Sodium sulfate, you have Na+, SO4 2-. So essentially, if we think about balancing the charge, we'll get Na2SO4. And finally, we have SO2 sulfur dioxide as part of your O-level case studies into nitrogen and sulfur chemistry. So each of these compounds may be used once, more than once, or not at all. Which compound produces ammonia? Produces ammonia when its aqueous solution is warm with sodium hydroxide and aluminium. So this is not looking at ammonium salt plus sodium hydroxide will give you ammonia, but this is in the presence of aluminium. So this is a test for nitrate, and these are straight from your paper 3 and also your theory qualitative analysis. So not necessarily just from your paper 3 where you're given the table, but also in a theory paper, whether paper 1, 2, or alternative practical, they can ask you this particular test for nitrate where you add in sodium hydroxide and heat it with aluminium, and you will get ammonia being produced. So that's going to be anything that contains nitrate. There will be silver nitrate. So I don't give the formula because we were given the thing in words. I was just going through the formula because there's something that a chemist should be able to do in the head while going through these options. Next one, contains ions with a -1 charge present in many fertilizer. So fertilizer, we are looking at nitrate fertilizers. Has a -1 charge. That's essentially what we're looking for. Because we can also be thinking about phosphorus, which is present at phosphate, but phosphate is a 3- charge, all right? And the other -1 charge would be the Cl- and Br-. They don't make sense because you don't use those for fertilizers. So which compound contain ions? So we know silver nitrate contains silver 1 ions and NO3- ions. So again, we are using silver nitrate for the second time, and because they did say each compound may be used once, more than once, or not at all. Contains ions with a +2 charge. So this is looking at the cation, which is +2 charge. So you got a couple of ionic compounds here. Things like Li+, Br-, this is +1. Magnesium carbonate, Mg2+, because it's from group 2. When you form noble gas configuration, you will want to lose 2 electrons and become like neon's electronic configuration. So this is the one that is the +2 cation, so the compound is magnesium carbonate. Next one, forms an orange color when it reacts with chlorine in aqueous solution. So this is a redox displacement reaction. So chlorine must be able to oxidize this particular species, meaning to say chlorine must oxidize this thing to give you something which is orange color in aqueous solution. This means in water. So we are looking at forming bromine. We are looking at forming aqueous bromine, and that can only work if we have Br minus going to Br2 plus 2 electrons. So there is a balanced chemical equation. So we're looking at something that has bromide, and lithium bromide is the obvious choice there, lithium bromide. So if you have bromide, chlorine, which is above bromine in the periodic table, chlorine will be a stronger oxidizing agent than bromine. So chlorine can oxidize bromide to bromine. Because the bromide lost the electrons, the bromide has undergone oxidation. The bromide has been oxidized. Next one is a hydrocarbon, so a compound containing carbon and hydrogen atoms only, that results from the bacterial decay of vegetable matter. That has to be methane, which is a greenhouse gas.